Hi everyone, welcome to our second seminar, and I'm your TA Gary. So this is today's outline. Today we are going to do three things. So first, I will have some comments on your assignment 1. And then second, there will be a further data session. I will also give you some hints for assignment 2. And then the third thing is I'm going to give you some information about term paper. For example, how and where to find data that you need in your term paper. So I will upload the suggested solution for assignment 1 in Athena. And make sure that even you did not solve the assignment in this way, you understand what and how we did it. Because actually, especially in Stata, there are many ways that you can do the assignment and give the same result. So you can also learn different ways of solving the same questions by looking at the suggested solution. And below, here are some general comments. So first, remember to write comments in your own words. And actually, there's one thing that I would like to remind you, because in the empirical exercise, the most important thing is that to give the answer to the questions. So the point is not the code itself, but the answers for the questions. For example, the question asks the interval of 95% confidence interval. So to answer these questions, the most important thing is not the coding, but what is the confidence interval. And I think it is better for you to put the answer, which is the confidence interval, in the comments, rather than only put the coding and also like what this coding is for in your comments. Yeah, so this is my suggestion. And second is that you should run the whole do file before handing it, because in this way, then you can check whether your code works or not. And actually, in assignment 1, I noticed generally there are two problems. So the first problem is in the writing part. So it's the question C. Basically, the question is asking about the expected value under the conditional probability. Maybe someone is confused by the notation, but actually the question is asking about the expected value under the conditional probability. But some people just directly use the marginal probability to, oh no, not marginal probability, but only use the joint probability to calculate it, so which is wrong. And the second problem is in the empirical exercise. So I see many people directly using the t-test commands to calculate the 95 confidence interval for difference in means. So basically, it will have small discrepancies with the true answers, because I think you can notice that when you calculate when you directly execute the t-test command, in the right lower corner, there will show the degrees of freedom. So, but when we calculate the 95 confidence interval of difference in means directly, actually we directly assume that the degrees of freedom should be infinite. So, which is also the assumption of normal distribution. But the t-test comment, um, the assumption of t-test comment is not infinite degrees of freedom, and which also depends on the number of observations. So of course we can see that this data set does not have infinite amount of observations. So at most, like it's like 5,000 or something. So actually, that's why if you directly use t-test command to calculate a 95% interval, it will create a small discrepancies between your answer and the true correct answer. So these are two problems that I noticed in assignment 1. But other than that, basically, I think the assignments are good. So now we are going to do our second part of today's seminar. So I'm going to teach you further the stata operation. So in stata exercise, I'm going to talk about three things. So the first is hypothesis test, and second is causality and regression, and the third is some hints about the exercise. So now I already opened the do file that we are going to exercise today. So first is the general setting. So today we are going to operate on different data set. So it's called LNU91. So now I will set my working directory and also import the data. So as you can see in the variable panel here, so now we are already import the data. So first, we are going to do the hypothesis test. So we will take LNU91 dataset as an example. So first, construct a hypothesis test of the mean years of schooling being equal to 12 years. So now we are going to test whether the mean years of schooling in this data set is equal to 12 years. So the null hypothesis is the mean of years of schooling is equal to 12. And of course, the alternative hypothesis is that actually the mean of the years of schooling is not equal to 12. So as you can see that if the alternative hypothesis is that the sample mean is not equal to a certain value, then which means that we should do a two-tailed test. So it's two-sided because it just means not equal. So actually how we do it, it's similar when we construct a confidence interval. So we need to calculate the standard error first and also get the numbers of observation as well. By knowing the numbers of observation and also the standard error, then we can calculate the t value, t statistics for this test. And by the t statistics, then we can get the p-value, and then we can use this p-value to know that whether this null hypothesis should be rejected or not. So this is the whole idea. And below, we are going to operate it on Stata. So to get the value that we need, then we first operate summary, and then we execute return list and scalar to store the value that we need. So you can see that by this process, we successfully store the value of mean, which is 11.56 in mean score, the value of the number of observation, which is 2,249 in N score, and also the value of SD, which is 3.1 in SD score. And then we can calculate the standard error of score, which is the standard deviation of score divided by the square root of the numbers of observations. By this, we can calculate the t statistics. So, which is mean of score minus 12 divided by standard error of score. And then we display it. Then we know that the t statistics is minus 6.59. So what does this t statistics means? Why should we calculate it like this? So I will explain it after I calculate the related p-value. So the relationship between t statistics and p-value is that. So as we can see that now the t statistics, the absolute value of t statistics, which is 6.59, is bigger than 1.96. So we can conclude that we can reject the null hypothesis at a 5% significance level, and also reject null hypothesis at 1%, since the absolute value of minus 6.59 is bigger than 2.58. So basically, t statistics is the value that whether you can reject a hypothesis at certain percentage or not. So if I explain it by using the whiteboard, I think it will be clearer. So if this is a normal distribution, sorry for my bad drawing, and this is the two-tailed test. And the way that we calculate the t statistics is that we use the mean score minus 12 and then divide it by the standard error of schooling. So the way that first we calculate the t-statistics is based on, so this mean school is the actual value that you get from the data. And wait a second. T-statistics equals to mean school minus 12 divided by SE schooling. So the mean school here is the actual value that you get from the data, and the 12 here is the hypothetical value that you want to test about. And then the standard error is the standard error. So if this is the normal distribution, so now the t-statistics is to test that. So if now the true mean, if now like we think that the value should be 12, then what is the probability that you see that you get the true value is the actual value? So it sounds a bit twisted. So it means that the mean of school is here, or here. So let me say the meaning of that t-statistics again. So t-statistics is to test what is the probability of like based on the hypothetical value is true, then what is the probability for this value to appear in the data set, which is actual. And the corresponding p-value is actually told the same thing. So the p-value wait a second. So p-value is the shaded area. P-value is the shaded area. And t-statistics is the position where the straight line lies. So basically, t-statistics and p-value, they talk about the same thing. So p-value, for example, p-value is 0.05, so which means that the shaded area is 0.05, and the t-statistics 1.96 is like 1.96 here and then minus 1.96 here. So basically t-statistics and p-value, they are talking about the same thing. So both of them is talking about, so based on what you hypothesis is true, then what is the probability that the actual value appears? So it's not that you directly say that the actual value is true or what. So is to say that now if you think that the mean of schooling is 12, but for example in actual there appears 4. So which means that the probability is quite low that the hypothetical mean should be 12, because actually you get the result of 4, which is quite far away from what you think as 12. Then which means that it's quite unlikely that your hypothetical value is true. So basically it means like unlikely, but it does not mean that this hypothesis is definitely false. So so actually the p-value and t-statistics only tell you what is more likely and what is not that likely, but actually they didn't say that whether the hypothesis is true or false, because even the hypothesis, even the null hypothesis is 1% true, which means that like unlikely, but it does not mean that it never happens. So maybe the true means is really 12, but what you calculate actually shows that the p-value is quite low, which means that it's unlikely, but it can be that actually the means is 12 as well. So this is what I would like to talk about the p-value and t-statistics. So sorry for my bad drawing and a bit messed explanation. So if you still have some questions about p-value and t-statistics, feel free to email me, or you can make an appointment with Zoom as well. So then I can explain it further to you. So now let's go back to the stata part and also the Duval part. So since now we have more understanding about t-statistics and also p-value, then we can calculate it as well. So now we finish the calculation of t-statistics, and we get that the t-statistics is minus 6.59. So as we can see that the t-statistics 6.59 is bigger than 1.96 and also 2.58, just like what we said. So we can say that we can reject the null hypothesis at 5% significance level and also 1% significance level. So actually the 5% and also the 1%, they are correspond just to the p-value. So what is the exact level of significance that you can reject H naught, which is null hypothesis? So actually this question asks, what is the probability that correspond to the t-statistics, which is minus 6.59? So to calculate this, then we need to calculate the p-value. So how we calculate it is try to find the shaded area, just like what we said in the normal distribution. So we use 2 times, so why we times 2 is because this is two-tailed test. So we use 2 times normal minus absolute value t stat 1. So this is how we find the shaded area under the t-statistics, which is p-value. And when we display it, you can see that it's extremely small. So it's 4.352 times 10 to the power of minus 11, so which actually is almost 0. So which means that, so we can compare, so we can back again to see our mean of school here. So which is 1156. So which is to tell us that so we can see that the mean is 11.56, the actual mean that we get, and based on our hypothesis, so we think that the value could be 12, but it turns out that the probability that if the hypothetical value is 12, the probability for us to get the actual value, which is 11.56, is extremely low. So which means that the true value is unlikely to be 12. So this is how we interpret the p-value and also t-statistics. So they means unlikely, but they don't mean that it never happens. So this is one important thing that I would like to remind you about the interpretation of t-statistics and also p-values. And similar with the confidence interval. So now we are going to compare the difference between two means, the difference in means. So now we are going to test the hypothesis that the average years of schooling is the same for women and men at a 5% significance level. So to get the summary statistics, we need for both females and males. So it's similar with what we did in the first case, but just separated for female and males. So the same, we still use the summary and also return this as scalar. So this is for female. And for male, we just do the similar things, but just change the specification after if. So female should be 0, and then like this. Then it's also the same to calculate the standard errors. Actually similar, or no, not similar, but actually the same as what we calculate about the confidence interval. So the way of calculating standard errors is consistent between the confidence interval and also hypothesis testing. So it's square root of variance of male divided by the numbers of males in the data set plus the variance of female divided by the number of females in the data set. So the difference in sample means, which is the score gap, is then the mean of male minus the mean of female. And then the t-statistics is consistent with the difference with certain value as well. So it's the same. The actual score gap minus the hypothetical score gap. So you can see here are no hypothesis that is the same. So which means that the hypothetical value should be 0. And then divided by the standard error of differences. So we can see that the t-statistics is 1.77, actually, which is smaller than 1.96. So based on the calculation of this data set, actually we cannot reject the null hypothesis at 5% level of significance. So which means that in this data set, based on our hypothesis that there is no gap between the schooling of females and males, the probability for us to get the score gap from our calculation is actually bigger than 5%. So which means that based on this data set, actually it is more likely that there should be no gap of schooling between female and male. Of course, it is a bit counterintuitive based on our actual experience and also what we heard from the news. But just based on this data set, so we cannot reject this null hypothesis at 5% level. So to calculate the p-value for this is the same. So we just do the same calculation and then display it. So we can see that the p-value is actually 0.075, which is 7.5%. And now we enter the last part of our today's data exercise, which is regression. So now we want to estimate the following wage equation. So we want to know that what is the relationship between wage and female. So female here is a binary variable, which is also the dummy variable. I think I explained it before. And so the dummy variable takes the value 1 if the observation is a female and 0 otherwise. So how we estimate this wage function is actually extremely straightforward in Stata. So basically, we use the reg command. So reg command stands for regression. So first, you put the main variable, which is also the dependent variable, in the first position. And then you put the independent variable in the second or third or fourth position. So here, since we only have one independent variable, so we just put this, and then just like this. So quite straightforward. And we execute this. So you can see that this reg command calculates quite comprehensively. So first, you can see that beta, which is the coefficient, is minus 17.5. So which means that males, if you are a female, averagely, on average, you have 17.5 crowns less than male, and we can see that the p-value for this is almost 0. So which means that quite likely that there is a gender wage gap based on this data set. So the average gender wage gap is statistically significant. Different from 0. So here, the hypothesis, the null hypothesis is that there is no gender wage gap. And the actual thing that we calculated is minus 17.5. And the standard error here is actually just the same as the standard error that we calculated before. So which is 1.108. So actually everything is the same, like consistent from the last seminar to today's seminar, from confidence interval to hypothesis testing to regression. So they are all consistent. The way that we calculate normality statistics or p-value as well. So after we run the regression, so how are we going to store our result? So how are we going to extract the value that we need from this regression command? So we still use scalar. So actually scalar is also a quite powerful command as well. So after we run this regression, so we put scalar, so beta, so p female. So first, there should be an underline in front of b. So this underline is indicating data that this is a regression. So, and female here is the variable name here, female. And then alpha, which stands for the intercept. So how we extract the intercept, which is here, like cons here, also like 88.75 here, out. So we also use underline B and then bracket and underline again, cons. So cons stands for constant because actually the intercept is a constant. And then how we take out the standard error for beta, which is here. So we also use underline B. No, wrong, sorry. So it's underline SE stands for standard error, and then the variable name stands for female. So if we do this, and then display, so the gender wage gap stands for beta. So which is minus 17.5, which we just saw in the regression comment. And the average wage for men is the intercept, so which should be alpha, is 88.75. So actually we can check whether the average wage for men is really 88.75. So to do this, we just use the summary command. So summarize wage if females equals 0. So you can see that here the mean is 88.75, so which is the same as the intercept. And then last one, we display the standard error. So which is 1.10. It's also consistent with what we saw in regression command. So you can see that in this regression, the average wage for men is the intercept. So and as well, quite reasonable is that the average wage for females should be alpha plus beta, because alpha is the average wage for men and beta stands for the general wage gap. So which means that if you are a female, then what will be your wage? Because beta stands for the gender wage gap, which is also like how gender affects your wage. So to calculate the wage for female, then we use alpha plus beta. And when we display it, it is 71.23. And if you feel a bit like doubt about the results, actually we can check it by using the summary command as well. So summary wage if females equals 1. So you can see that they are consistent. So it's also like 71.2319. So so it becomes like 19 rather than 18 here. It's just because it can only show the 4 digits. So that's why it makes it like 19. But actually, basically, it means they are the same. Of course, you can also run the regression using male as a dummy, but not female as a dummy. So basically, the result will be the same, but just in different sign. So which I mean is that, so if you use female as a dummy, then in the intercept, it will show the average male wage. But if you use male as a dummy, then the intercept will be female wage. And if you use female as a dummy variable, beta will show that how the female affects wage, which is like negative in this case. So if you use male as a dummy, then the beta will turn positive, because in this case, the wage of male is higher than the female. So now if we use male as a dummy, then we generate male equals 0, and then replace male equals 1 if female equals 0. So by this way, then we create a dummy variable which called male. So and then we run the regression. So which is wage and then male. So you can see that now the beta just turned the sign, not side, sorry. So just turn the sign from negative to positive, because now we use male as the variable. So which means that in this case, male has a positive effect on average wage. So how we calculate the t-statistics and p-value is the same when we calculated the case when the female is a dummy variable. So the t-beta should be the actual beta minus 0. So the same. So this beta is the actual beta that we calculated, and 0 is the hypothetical value, and then divided by the standard error of beta. And then we display the t-statistics of beta. So you can see here, the t-statistics of beta is minus 15.8. And we can run the regression to check it. So you can see that they are the same here. So it's minus 15.8 in regression, and also minus 15.8 if we calculate it by hand. Yeah, basically like manually, yes. And to calculate it, the confidence interval for beta, so it's also the same spirit as what we just said in the last seminar. So the confidence interval is the mean plus 1.96 if it is the 95-point confidence interval case, and then times the standard error. So it should be beta minus 1.96 times standard error of beta, and then the upper bound is just become plus 1.96 times standard error of beta. So if we display the results, it shows that the lower bound is minus 19.69, and the lower bound, the upper bound is minus 15.34. Actually, you can see that it is the same as what the regression command calculates. So everything is consistent. So this is about the regression and also the confidence interval for the beta. And then the last one is talking about the causality and also the multi-regression case. So I think I told a bit about the multi-regression in the beginning of the introduction of regression. So basically in Stata, to run the multiple regression is extremely easy. So you just put the second and third and fourth variables just after it. So just remember that in the regression command, the first one is always dependent variable. And then after the first position, which is a dependent variable, the things after the first position is all the independent variables. So for example, you can see here the multiple regression case is I think that not only gender but also the years of schooling is related to wage. So I also put school after women. So it's Yeah, so basically this is how we run the regression. And there's one thing that I definitely will talk about um, in the seminars afterwards, but I would like to talk about it a bit now as well. So it's called conditional mean zero, so which is the core of the regression, and it's actually also the core of the like the empirical research nowadays. So which means that if conditional mean zero holds, then the conditional distribution of the error term given a regressor, which is female, has a mean of zero. So which means that um, if you think um, that women really cause the gender wage gap. So because um, we know that like relation does not means causation. So x and y is related does not mean that x must cause y. But if this condition holds, so which means that if female and the error term is not related, then we can say that female directly affect wage. But of course, we know that actually female and wage, actually they have some common like factors. So for example, education, because actually female is related to education and wage as well. And also, for example, like female is related, how female affects wages or related to family background. So actually, like the assumption of conditional mean zero is extremely difficult to hold in the reality. So I will talk about this afterwards because this is also related to your term paper. So you can take this in mind about the assumption of conditional mean zero, and also like this does not hold in the most situation in reality, and this will be the a core thing that you should mention afterwards in the term paper. And yes, so basically this is the data part. And now we go back to our last part. So for term paper, below are things that you can start to think about. So first is a question that you would like to investigate. So you should motivate it well. So for example, why is it interesting? And also like what's the relationship that you expect and why. So for example, I can take just the things that we did a few minutes ago. So for example, you expect that there should be a gender gap of schooling, but it turns out that maybe the data set that you find does not show this relationship, and then it actually creates some conflicts between your expectation and the actual result. And then you can think about like why this has happened and other things. And then second, maybe you would like to refer to previous literature and studies as well. So you can find your inspiration from the past studies and also even from news as well. And then explain your data set. So you should talk about where the data set is from. And also like it, of course, should contain the relevant variables. So the things that you would like to put, and also a set of control variables to account for omitted variable biases. So I will talk about this afterwards. no worries. And then fourth is that you would like to provide some summary and also descriptive statistics using like plots, tables, and histograms. And also, of course, the regression results. And also the last one, um, actually, I would think that this should be the most important one in your term paper, which is the interpretation results. Because actually, we can see that it's really straightforward to run the regression. So you just put reg and the dependent variable and also the independent variables. So actually, there is no like there is like there has no difficulties in running the regressions. So the most important thing, and actually where we can see like your understanding of this course is not the regression results, but actually how you interpret the statistics. And yeah, and we will talk more about the term paper in the future as well. So where you can find a data set. So first, you can use the data from Stock and Watson, and also um, remember, like we don't teach time series data in this course, so you can only use the cross-sectional or panel data. And below are some suggestions of sites that you can download data. So if you would like to try for the country level data, you can find it in Eurostat and World Bank, and or from the Statistics Sweden and also the like BRAD website. Or if you would like to combine some data from Sweden, so other than Statistics Sweden, you can also take a look at the Brottsfölje byggande rådet, so which is like stands for BRÅ. Yeah, so I think you understand it more, even like more than me. So which is about crime statistics in Sweden. And other than coming up with a new topic, it is also allowed to replicate an existing paper. So actually many economists have data and script files of their work available already on their home pages. So you can visit them as well, or actually you can also replicate the works by our like, professor in SU as well. Yeah, and below are two websites that you can find the papers to replicate. So yeah, so this is today's seminar, and thank you very much.